So let's look at an example of test circle with exception and circle with exception class. So this is a program test with exceptions, test circle with exceptions. So let's say we need to surrounding the constructor with try catch, because circle with exception class constructor when we pass radius is called set radius, and set radius is throws, so that means it's check, right? So throw the illegal argument exceptions. So since it's check, then we have to do try catch to handle. This is check exceptions when we use the method circle with exception to construct instance. Even circle with exception doesn't have throw, but set radius does have throw. So that's why we have to handle that. Now, if I create this and not handle it, run the exceptions, see, it's going to happen errors because we not handle it. Radius cannot be negative, right? So now we're going to handle it. Let's create okay. So since handle, at first we get number of object is going to return like how many object has been created. From this constructor is to increment what is created. So first we create the first object with radius 5, then pass 5 in set radius, and set radius say hey, it's greater than or equal to 0, then we can set the radius. But when we get to -5, we pass -5 in, we throw the radius cannot be negative. So that's why the exception has been thrown here. And now this is important thing. Look, when the exception is catch, you see it on your test. When exception is catch at this point, it's going to jump out and handle here. If you never reach C3, it's jump out and print out the throw radius cannot be negative, and then it's continue. Program never terminate, right? Before when we remove try catch didn't handle, program terminates. This one never terminate, but it will skip this statement. It will never do any statement inside your try when it's reached errors. So that's why number of object created is just 1. Revise the code. Let's revise the code to see the behavior of the code when I separate try catch to create each instance individually, like 5, -5, and 0, and see how many object has been created. So in this case, there are 2 objects created, because first one is good, is 1. Second one, though, which is radius cannot be negative, and the programs to continue to create a third. So that's why 2 objects has been created. So if you do try catch separately, so that's when you use try catch. It depending on the situation. If you still want to create objects, then you should separate them, or you can just do iterating a loop, because this is like looping, repeating, right? Per object. But if you say once one object cannot be created, then the rest cannot, then you should do the other way, right? Now Rethrowing exceptions. Like you can also say, hey, I want to handle something, and then I will throw again. You can rethrow it again too. And finally, clause. You can also say, I try to do this. If there's an error, so I handle it. After that, I still want to do the finally clause, final statements. Like for example, if there's no exception in the statements, final statement, either there's an exception or not, it's still going to do the final statements. The final block is always executed. And then program continues. Now, suppose an exception happen at statement 2. So it's going to throw exception, handle, just like our negative bit radius, right? But it still do the finally. So whatever statement that in this final block is always executed, either has an errors or not, and then continue the program. So this is when we have multiple exceptions. So if statement 2 throw exception of type exception 2, then it's going to jump to exception 2, not exception 1. Alright, exception 2, handling it. Now, if exception 2 is rethrowing exception, it's going to rethrow back. And finally, block is going to still doing it, no matter what. And before rethrowing back, it has to go to do final first, and then it's come back to rethrow the exception. Right, and then it's just transfer back to the one who called the method. So this sequence you should know to prepare for your test. Okay, you see a different thing, and you should be able to tell what the final output is. Cautions when using exceptions. Exception handling separates error handling code from normal programming tasks, making program easier to read and to modify. So be aware. However, that exception handling usually requires more time and resources because it requires instantiating a new exception object, rolling back the call stack, and propagating the errors to the calling methods. So the benefit of exception we see make the program easy to read, easy to handle all the runtime exceptions, easy to modify, but also cost in terms of resources. Need more memory and time to process. So program slower, occupy more spaces. So that's why we don't want to check all the time exceptions. Compiler, that's why they have some unchecked exceptions, like index outbound exceptions. Otherwise, it's just too cumbersome. So you always have to notice when to use and when not to use. Exception occurs in the method if you want the exception to be processed by its caller. You should create an exception object and throw it. If you can handle the exception in the method where it occurs, there's no need to throw it. So this is just showing when to use exception, when to throw it. Like if you know the errors you want to handle, then just to try catch. If you don't know, then let the caller of your method handle it by just declaring throws at the method header if you want it to be checked. Again, when to use exceptions, when should you use the try catch block in the code? You should use it to deal with unexpected errors conditions. Do not use it deal with simple expected situation. For example, the following code. Reference variable.toString. We want to print that. Try to print. We know that this is going to throw a null pointer exception if the ref var never instantiate. Then it's going to refer var is null. Like, it's better to replace by if ref var not equals to null, then we print, else just ref var is null. Because it's not necessary to use try catch. Alright, so we have seen the exceptions that we use class of exception instantiate from the libraries, Java libraries. You can also create and customize your own exception classes. So use exception classes in the API whenever possible. You don't need to declare every time if APIs already exist. But if not, then define your custom exception classes if the predefined classes are not sufficient. Define custom exception classes by extending exception or subclass of exception. So you're going to extend from exception class from the library when you define this, or even subclass of that. Like you can do number exceptions extend from arithmetic exceptions, or you can do my exception extends from exception from the library. So let's look at some of the example of the custom exception class. Invalid radius exception, circle with radius exception, test circle with radius exception. So set radius method throw an exception if the radius is negative. Suppose you wish to pass the radius to the handler, you have to create custom exception class. So this is the test instantiated set, and we set invalid radius exception. This is our own exception that we created. So let's take a look at invalid radius exception. So when you create your customized exception, you can just extend exception, and we have the radius as attributes. Then we can just say invalid. This is a constructor which is called the super, which is referred to the constructor of the exception class, and add the invalid values of the radius. Set this radius to radius, and you can get the radius that is invalid. So that's how you implement the exception. Always extends from exception and use super constructor inside your custom constructor exception. And this is just inside a circle with radius exception. We have set radius, which throw invalid radius exception, which is customized version. So using it is the same. Assertions. An assertion is a Java statement that enables you to assert an assumption about your program. An assertion contains a Boolean expression that should be true during program execution. Assertion can be used to assure program correctness and avoid logic errors. An assertion is declared using the new Java keyword assert in JDK 1.4 as follows, right? Assert assertion or assert assertion detail message, where assertion is a Boolean expression and detail message is a primitive type or an object value. So this is when you declare to use, just like when you declare like in and in name, right? But this is like assertion is a Boolean expressions